So you've found the perfect home. But high mortgage rates have you second-guessing. The Churchill Mortgage team says waiting to buy can be a costly mistake. Try their free 15-minute analysis to see the difference between buying now versus waiting for lower rates. Visit churchillmortgage.com to learn a smarter way to build wealth through home ownership. This is a paid advertisement. NMLS ID 1591. NMLS ConsumerAccess.org. Equal Housing Lender. 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
Thanks for joining us on another episode of Space Nuts. Always great to have your company. And on this week's show, we've got a couple of asteroid stories to talk about. One that hit China about 50,000 years ago, and a potential asteroid strike on Earth. Looks like it's been averted, not due to anything we did. It just has been reported in the news as no longer going to hit Earth. So how could it be both? We'll look at that. There's a strange black hole that has been discovered that's spinning on its side. And we're going to answer some text questions today because we haven't done any for a while about the speed of light, about whether or not we're living in a simulation. That's a really good one. And when will we set foot on Mars, and could we live on Io and Titan one day? Those stories coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
My name is Andrew Dunkley, your host, and we appreciate your support. And with me, as always, is Professor Fred Watson, astronomer at large. Hello, Fred.
What a surprise. It's me.
Yes. I was expecting someone completely different.
No. One day that'll happen and you'll think, what? No,
I don't know about that.
Well, maybe not. Anyway, I'm here, and thank you, Andrew. Always good to be part of Space Nuts.
I appreciate it. Now, we've got a bit to get through, and we'll start off by talking about a couple of asteroids, one that hit the Earth about 50,000 years ago, and one that was due to hit the Earth not too long from now, but now it won't. We'll get to that. But this impact crater that they've discovered is in China. Is this only a recent discovery?
It is, yes, a couple of years ago, and I think what we're seeing now is the scientific paper that describes what has been found. It's in the journal Meteorics and Planetary Science, and so it's a really interesting one because China, until a couple of years ago, only had one known impact crater. It's called the Shuyang crater, which was about, or still is, I should say. It is about, I think it's about 1.2 or thereabouts kilometers in diameter, maybe a little bit bigger than that. But the new one, which has been discovered in a place called Yilan, that is bigger. And in fact, it's now a record breaker because it's been dated, and this is all reported in the paper I mentioned, by carbon-14 dating of charcoal, because it would have, the impact would have burned wood, and there's actually probably formed a lake in the crater at one point as well, and there's lake sediments which have been dated as well. These in the geological record,
yep.
And the suggestion is that it was formed between 46,000 and 53,000 years ago, which is about the same age as the meteor crater that you and I have both visited in Arizona, the Barringer crater. That's about 50,000 years old. But the interesting thing is that the Yilan crater, the newly discovered one, is bigger than the Arizona crater at about 1.85 kilometers in diameter, compared with about 1.2 kilometers for the meteor crater in Arizona. And that makes it the biggest crater on Earth under 100,000 years old.
Okay, right. So there are older ones that are bigger. Is that what you're saying?
Yes, that's right. There are.
The Chicxulub crater would probably count.
Yeah, it would count. And you sort of, in a sense, that's that's it's worth an interesting statistic, because the further back in time we go, the bigger the objects we expect to find still roaming around the solar system in a wanton and uncontrolled way. Even though 100,000 years is not long compared with the 4.6 billion years age of the Earth. But as time progresses, you get fewer large bodies. And of course, now we're in this situation where bodies greater than a kilometre, pretty well all of them, I think it's a 90% completeness, have been discovered when you do the statistics. So, rather interesting. What would have formed it? Probably an object, probably not that much bigger than the thing that exploded over Tunguska back in 1908. But more solid. It's thought to have been probably an iron meteorite or an iron asteroid, which means it's a part of the chunk of the core of a protoplanet, a planet that was in the process of forming, because all the iron sinks to the middle. And so you get these iron asteroids and iron meteorites that actually are the remnants of the cores of planets that have been banged into by other things. Or planetesimals is actually the correct term. These small objects, protoplanets, is what they grow into. Planetesimals are the size of a large asteroid, but they're big enough to have differentiated. That's to say, the iron has sunk to the middle under its own gravity. So it's been hot enough for that iron to flow, and big enough to be differentiated. So what we think this might have been is the remnants of one of those. There is evidence from the bottom of the crater that it was indeed an impact crater rather than something volcanic. There's shocked quartz, which is spoken about a lot in impact circles. This is quartz that's basically been shocked by the temperature of the impact. There's melted granite. There's actually volcanic glass, or when you get high enough temperatures with rock, with silicates, you form glass. But it's got holes in it which would have had gas bubbles in, and lots of other symptoms of an impact. And it's actually worth following up on the web, if our listeners care to do that, because there's some rather nice aerial photography. It's actually Landsat photography, I think, showing this crater looking exactly like an impact crater. It's in the hills in farming country. It's a sort of mountain range. And it's incomplete. The southeastern quadrant is missing. It's not clear why that should be, whether it's by erosion or some sort of asymmetry in the formation of the crater. But very interesting discovery. And as I said, it's worth looking up the Landsat images, because it's very crater-like. It's just a circular feature.
If you do a search for young impact crater China, you'll probably find it. It's on the SciTech Daily website. A great story about it there. I was wondering, Fred, what China might have been like 50,000 years ago. I'm guessing there would have only been 500 million people. I don't know.
It would have been very sparsely populated, I think. I mean, China's a very big country. It's got a large land area. And yes, the climate would have certainly been different, because we know that since then there's been at least one ice age and possibly more. A different sort of place. One little detail that I really liked, it's apparently in really heavily forested country, and that might be why it's not really been recognised. Apparently it's the autumnal foliage on the trees that make it show up and in the Landsat image. But it's got a name, a local name, which I'm going to mispronounce probably, Quanshan, and apparently that translates as circular mountain ridge. So the locals knew it as a circular feature. That's right.
Yeah, I'm guessing they probably didn't realise what it was caused by.
That's right.
You mentioned the comparison to the size of the object with Tunguska. But I remember us recently talking about Tunguska possibly being a planet grazer. It didn't actually hit the ground at all. So
That's right.
But this one did. Obviously, it was an impact crater. But Tunguska was something that exploded or grazed the Earth.
Yes,
rather than hit it directly.
A detonation in the atmosphere, which this might have done as well. It may well have burned up some of its material in the atmosphere, but certainly was big enough to cause a crater on Earth. And that would have been locally pretty devastating. There would have been effects. There would have been a lot of material thrown up into the atmosphere, so there would have been possibly a bit of temperature change in the area, maybe global effects like we've seen curious atmospheric phenomena because of the Tonga volcano putting aerosols and dust into the atmosphere. Been a lot of really unusual sunsets and things like that, which I think are still going on. I don't know. I haven't seen a sunset for about 3 weeks because of the cloud that we've got here.
Yes, well, we've had plenty of cloudy days in recent weeks as well. It's been a very unusual summer for us, much cooler than normal. We've had temperatures out here that have just barely scraped into the low 30s when we're normally pushing towards 40 this time of year. It's a very, very mild summer, which correlates with a heck of a lot of rain. And we've seen all those floods up north of where I am, about 6 hours drive from where I am, around northeastern New South Wales and southeast Queensland. That's just a horrible tragedy with so much floodwater. And places like Lismore, for example, where I lived for a short time, worked on the local radio station there, 2LM, for a while, and they've had a record-breaking flood. They haven't had a flood that big since records began. It's just been incredible what's been happening. I did ask a few people overseas what they thought of the floods, and they went, "What floods?" All that's on in the news in other countries is Ukraine, for obvious reasons. But the floods have barely rated a mention outside of Australia, from what I understand. But yeah, it's been pretty horrendous here for a lot of people, and it's not over yet. There's a big East Coast low coming in on you, Fred, isn't there?
That's right. Yes, I'm keeping an eye on the rain radar. I nipped out just a minute ago to clear gum nuts off one of our drains that blocks the drain up.
Yeah, they do.
Floods our back path. So yeah.
Okay, well, let's continue on with our discussion about asteroids, because we've talked about a couple of strikes in recent times on Earth, and there was one particular asteroid that was in the news only in the last week or so, 2022 AE1, which they thought would impact Earth sometime in the middle of next year. And now all of a sudden it won't. And of course, the popular press is jumping all over this and saying, "Oh gosh, it moved. What happened? How did that, don't they move in a straight line?" No, they don't. But this is an unusual case.
It is a little bit, yeah. So this was discovered on the 7th of January. You're quite right. It was 2022 AE1. And the thing about discovering asteroids, Andrew, is that what you're looking at, all you're seeing is a dot of light. So just taking one image of the sky doesn't reveal an asteroid. But if you take two and you detect an object that's moving between the two images, maybe if they're an hour apart or a few minutes apart or something like that, you'll get movement in it. And that tells you that it's a nearby object, that it's an asteroid. But you need 3 observations to get a first approximation of its orbit. And that's what happened. There were 3 observations made. An orbit was calculated. This is all done automatically now. There's a thing called the Asteroid Orbit Determination Automatic System, which is, basically it's actually part of ESA's Near Earth Object Coordination Center. So it all happens automatically, and it flags the asteroid as having a risk on one or both of the 2 scales that we measure asteroid risk, the Torino scale and the Palermo scale. Both of them are, what they do is they rank collision probability with size, the amount of energy that this thing's going to deliver, and essentially give you a score. So this got flagged on the Palermo scale because those first observations indicated if I remember rightly, it was going to be the 4th of July when it was going to hit
Yes,
the
I
Earth.
think that was right.
2023.
4th of July, 2023. Yeah.
And so more observations were made in subsequent nights, but then the thing got too near to the moon to observe, so it was sort of drowned out by the moon. And at that stage, it was still an object of interest. It was still something that had a chance of hitting the Earth in 2023. It was the 12th to the 19th of January when the object couldn't be seen because the moon was too bright and too near to it. So they got further observations after that. I can't remember whether it was the 20th of January. It's thereabouts. And that next observation immediately ruled out the possibility of a collision. And so what's happening here, Andrew, is that it's all about how much of what we call the arc, how much of an orbit you can observe. And if you've got just a short chunk, like the amount of an orbit that an asteroid covers in one night, you can get a deduction of what its orbit is, but it's got huge uncertainties. Because you're only observing over a very tiny arc of the orbit. And as you progress, you track the object over subsequent nights, you can actually refine the orbit, and those probabilities come down. Those uncertainties in where it will be down the track are reduced. And that's why when it was observed over a long enough arc after the full moon period, it was immediately obvious that this was not going to collide with the Earth, because the probability shrinks enough that the uncertainty in the measurement shrinks enough that it tells you that there won't be a collision.
Yeah, it's going to miss us by a few million.
It's 10 million kilometres.
10 million kilometres, yeah. I'm fascinated by the Torino scale. It looks like a risk matrix that you do.
It is.
Like when I worked for the ABC, we used to have to do risk matrix assessments before we did outside broadcast to decide whether or not it was too dangerous. But this one, it gives you the size of the object and the collision probability and the ultimate effect if it does hit.
Yeah.
So a 5 kilometre object with a certain collision probability would have a global effect.
It would.
And it goes down. This one, they reckon, would have been a localised effect.
That's right, yeah. Once again, an object actually probably similar in size to maybe the Chelyabinsk impactor, the one that exploded over Russia back in 2013.
So that rates an 8 on the Torino scale.
Yeah,
that's still way up there. It prompts me to ask another question about asteroids and their impacts on Earth. Are there certain parts of the planet that can't get hit because of the way the angles work, or is everything exposed?
It's a good question, actually. Yes, everything is exposed because whilst asteroids, I guess if you think of asteroids mostly being in the plane of the solar system, then as you get nearer the poles, your probability is reduced. Although it's still possible for impacts to happen near the poles. But in fact, with asteroids, their orbital inclination ranges over quite a high level. They are concentrated to the plane of the solar system, but there's some that come in at quite high angles. And, the Earth's just doesn't matter which direction you're coming in from, the Earth's the same target. And if they're coming in over the pole, then, you can get them near the poles as well.
Interesting. Just wondered about that. Okay.
Yeah.
Now, if you want to find out more about this near miss that's no longer a near miss, or the near hit that's no longer a near hit, about 2022 AE1, there's a great story about it on the phys.org website, phys.org. This is Space Nuts with Andrew Dunkley and Fred Watson. Let me take a moment to talk to you about our sponsor, NordVPN. Now, we've got a special deal going at the moment. As a Space Nuts listener, a special price for you, which I'll get to shortly. But why do you need a virtual private network? Well, protection, basically. Cybercrime has become a multi-billion-dollar industry worldwide, and there are a lot of people who spend all their time looking at ways of hacking people like you and me and your friends and your family to get hold of your money. It's really that simple, looking for keywords, looking for passwords, looking for patterns in your typing when you're on your computer. You can stop all that as simply as putting on a VPN service. And the best one in the business is NordVPN. It makes your online data unreadable to outsiders, and that includes hackers. It secures your PC, your laptop, your smart device, even your smartphone. You can, with NordVPN, protect up to 6 devices at the same time. And another way it protects you is it changes your IP address. So they don't really know who you are or where you're from. And it opens you up to the world because it breaks down those geo-blocking barriers. Nord is fast. It's the fastest VPN in the business. It's reliable. There's 24-hour, 7-day-a-week support, and it's highly revered. It gets a lot of good press, basically. So take advantage of the offer that's available now as a Space Nuts listener through the URL nordvpn.com/spacenuts. That's nordvpn.com/spacenuts. And the code you'll need is SpaceNuts. Grab the deal today for a huge discount off NordVPN plus 1 month. It's risk-free. There's a 30-day money-back guarantee. And because it's their 10th birthday, there's a bonus gift. That's nordvpn.com/spacenuts. Use the code word SpaceNuts. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, if you want to help us out on Space Nuts, but you don't want to kick the can for, a monthly contribution as a patron, although that is certainly something that is most welcome as well, you can do a review. Now, I don't know which podcast distributor you use. There are many, and we're on all of them. But if you like the program and want to leave a review, that would be greatly appreciated. The more reviews that we get, the more attention we get, and the higher up in the rankings we go, and the more people that listen, and that increases our community and makes for a lot more fun and enjoyment. And yeah, it helps out a lot. So if you'd like to leave a review on your favourite podcast distributor, that would be fabulous. So we'll leave that one with you. And if you are interested in becoming a patron, jump on our website, spacenutspodcast.com or spacenutz.io. Now, Fred, this is a rather interesting black hole story, and this one's a little bit different because they're describing this in the Sci-Tech Daily website as a death spiral. This is a black hole that's sort of rotating flat on its back, like Uranus, I guess.
It's a bit, yes, that's right. It's not quite as acute as Uranus is, but it's definitely well tilted over. So this is research that's come from scientists actually in a place where I visited. I may even have met some of the scientists in question up in Finland, the University of Turku in Finland, and their Tuora Observatory, which is in a lovely spot outside Turku. That's where these researchers are based, but they've used a telescope in La Palma that I'm also familiar with, the Nordic Optical Telescope, operated by the Finns and the Danes. We always used to joke about. I used to work quite a lot in La Palma in the Canary Islands, and watched the Nordic Optical Telescope being built back in the 90s. It was always a joke that its acronym is NOT. So this was not the telescope. It's the Nordic Optical Telescope, the NOT. Does great stuff, though. Great work. If I remember rightly, it's about a 3.5 meter, I think. Is that correct? Right. Something like that. Anyway.
And you said you saw it being built in
Indeed,
the 90s.
Yeah.
The 1890s?
Thanks, Andrew. That was wide open for that one, wasn't it? Yes, it was the 1890s. That's right. Actually, you've taken me straight back to it. It wasn't quite the 1890s. It was a bit earlier than that. But that was where Charles Piazzi Smythe, who was eventually the Astronomer Royal for Scotland, did his first work on determining that mountains are great places to build observatories, and he did it in the Canary Islands.
There you are.
Not on La Palma, but on Tenerife, and he hauled his gear up to Teide, which is the volcanic peak on Tenerife, and determined that the exquisite viewing that you get from those heights is well worth the trouble. And of course, that was the start of mountain astronomy. It was a bit before the 1890s. There you go. There's a digression.
How about that?
Yeah. But to the story. So what we've got, and this was discovered by X-ray astronomers. I think the follow-up work was done with the Nordic Optical Telescope. It's an object called, wait for it, MAXI J1820 plus 070, and it's an X-ray source. And what we have is a binary pair with a massive star in orbit around a black hole. And the star is close enough that material is leaching from the star into the black hole's accretion disk. So you've got this star in orbit around the black hole, a disk of material which is rapidly spinning, highly energetic. That's where the X-rays come from. And it's the stuff swirling down the plug hole before it gets swallowed up by the black hole. Yep. So that's a fairly standard scenario. We see that very frequently. But what's not standard is that, like many black holes, this one squirts out material from its poles. And that's material that has been kind of grabbed by the magnetic fields of the black hole from the accretion disk and sent out, usually at right angles to the accretion disk. So it's coming out, along the axis of rotation. And it is indeed the axis of rotation of the black hole. We talked about this last week. How can something with 0 dimensions have an axis of rotation? Well, it does. But in this case, the stuff is being squirted out, yes, in form of jets of material, which once again can be detected by X-rays and radio telescopes too. But the jet is tilted over at more than 40 degrees to the perpendicular to the accretion disk, and that is bizarre. In fact, it's the first time that has ever been seen.
And the obvious question is, why do we think it's doing that?
Yeah. So, as the mentioned SciTech Daily, as the article says, the finding challenges current theoretical models of black hole formation. There you are. That's it in a nutshell. The theory at the moment struggles to allow something like this. I think it's the lead author he's made a comment about this. He's got a lovely Finnish name, Juri Putanen. And he's a professor of astronomy in Turku University. And he says the difference of more than 40 degrees between the orbital axis and the black hole spin was completely unexpected. Scientists have often assumed this distance to be very small when they've modeled the behavior of matter in a curved space-time around a black hole. The current models are already really complex, and the new findings force us to add a new dimension to them. In other words, I think the theoreticians are struggling to make this fit the normal paradigm for how black holes form and how they behave when they're formed. It's such an extraordinary and unexpected result.
Indeed. And you couldn't sort of simply say, well, something must have knocked it over because it's a black hole. I mean, it's not that simple.
Yeah, that's right. It's not that simple. It sort of makes you wonder whether it's I don't know, no, that doesn't fit either. I was just going to theorize that the accretion disk has slipped. But of course, the accretion disk, the plane of the accretion disk is the same plane in which the companion star orbits, because it's feeding material onto the accretion disk. So that doesn't fit the picture either. I think it's the black hole that's been knocked over, Andrew. I think you've got it in a nutshell there, but I don't know how it's been done.
No, maybe another black hole.
It could just be the way it's formed, some really peculiar phenomenon when the black hole has collapsed from the nucleus of a star at the end of its life.
Maybe there was some kind of disturbance at the moment of formation.
Could be. Who knows what it might have been?
Yeah, but it's fascinating, and you can go to the SciTech Daily website and read all about it. It's great little animation there showing what's happening as well. This is Space Nuts. Thanks for joining us. Andrew Dunkley here with Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, if you haven't visited our website lately, why not do so? It's a lot of fun, plenty of things to do, including the Space Nuts shop, which has got all sorts of goodies available if you're interested, such as, let's just go through the list. Bubble-free stickers. There are mugs. I've got one on top of my head right there. See, that's one of our mugs. Yeah. There are caps, there are shirts, there are hoodies, there are spiral notebooks, there are socks. I've got a pair of those too, not on at the moment. Bucket hats, and the list goes on. And of course, Fred's books are all available through the Space Nuts shops, and some other galah who thinks he's a writer has put books on there too. It's all available through the Space Nuts shop on our website, spacenutspodcast.com or spacenuts.io. Alrighty, Fred, let's answer some questions. We've got a few to do today. These are all text questions. We haven't done a bunch of text questions in a while, so let's hear from Jeffrey in Colorado. Dear Fred and Andrew, I feel like my brain is broken and need help putting it back together. We all know how that feels. He says, we all know the speed of light in a vacuum is constant. In a recent episode, Fred said that light travels slower in glass than a vacuum. What if you fired photons into a glass rod in space? Would they go in at the speed of light, travel slower in the glass, and then come out at the speed of light? Can you help explain this and correct my faulty logic? Thanks for a wonderful show. I can't tell you how many times it's taken me down the rabbit hole learning new things. Cheers, Jeff. Thank you, Jeff. Lovely to hear from you. Speed of light. We know it can be affected by gravity. We know it can be affected by, all sorts of things. But he's brought up an interesting experiment, I think.
Yeah, that's right. And actually, he's right on the money. What he's saying is all correct. If you've got a long glass rod in space, and there might be such things, who knows, light goes in at one end, it slows down to the speed within glass at the other end as it travels through and pops out at the other end. So it's quite interesting because that, in a sense, is an optical delay. If you imagine a beam of light that's traveling in space, two beams of light, one hits the glass rod and the other doesn't, two parallel beams of light, I should say. When they come out the other end, the one that was in the glass rod is behind the one that wasn't. So it's good stuff. Well,
and that's just a natural phenomenon.
It is. It's the process of refraction. And it's not just glass, of course. Any medium will do that. Any transparent medium. Water, of course, is another. And even air. Light is moving slower in air than it is in a vacuum. Not by very much.
If I'm outside in the sun, am I getting hit harder by the photons than if I'm standing inside behind the window?
You are, but it's nothing to. That's because the glass absorbs some of the ultraviolet of the sun's light, but not much actually. You can still get very sunburned through a window. Yeah,
you can indeed. Yeah. All right, a short, easy answer for.
I hope so. Yeah, I hope so.
Let's move on to our next question. Oh, thanks, Jeffrey. This from Lawrence, who lives near Glasgow, Scotland. Hi, guys. Long-time listener, first-time question asker. I felt kind of bad about asking a question before I was actually supporting you in some way, so I bit the bullet this morning and signed up via Patreon. Oh, thank you.
Yeah.
My wife and I have been listening for years. We find your dulcet tones quite the sleep aid.
Look, we'll take whatever we get.
Like a warm, cozy blanket, he says, if you will. Nice. Anyway, questions. Given the Moore's law, the vast increase in computer graphics quality, AI, etc., do you think we live in a simulation? That's his first question. His second question is, when on Earth, if you pardon the pun, will we actually set foot on Mars? We'll get to that. Moore's law.
Yeah, it was I set out in the 80s, I think, Moore's law, and it basically is to do with the rate at which the processing and storage power of computers increases. It's something like, I might have this wrong, and I'm sure people will correct me because more people know more about Moore's law than I do. It's something like it doubles every 3 years or something of that sort. It might even be less than that. And of course, we've seen that, in every facet of our lives. Especially with storage, you can now buy miniature USB sticks that are about the size of a thimble that have 64 gigs of storage on them. Just incredible stuff that we would never have dreamed of 20 years ago. In fact, I remember the party we had at the University of St Andrews when I was studying there in the 60s. We had a party when our IBM 360 machine was upgraded to 256 kilobytes of storage. That was, just extraordinary.
Well, you look at it compared to the computer on Apollo 11.
Yes,
you've got more computing power,
absolutely,
in your mobile phone.
Yeah, probably even in your watch.
That's my phone. If you're watching on YouTube, that's what my grandchildren gave me for Christmas. My phone cover. That's me playing golf.
Very, very nicely done too.
Yes, very nice. But yeah, and I remember when thumb drives or flash drives first came out, they were like $250, and they could hold about, I don't know,
250 megs
kilobytes or something.
Yeah.
Some ridiculously low amount of data.
Yeah. So just carrying on from that Moore's law plays a big part in how science is carried out. And I'm thinking particularly of the square kilometre array. When that was being planned more than 10 years ago, the scientists who were designing it and projecting how it might be built knew that the computing power to deal with the data that comes from it simply did not exist yet at that time. And I think it may even not quite exist yet either, because the square kilometre array is finally supposed to come on stream towards the end of the decade. It will deliver 7 terabytes per second, I think I'm right, in terms of the data flow. Just colossal, hard to get your head around. And so, I might have that wrong, it might be per minute, but it's a very small interval and it's a lot of data. And so, you need to be really ahead of the curve on Moore's law to handle that, and that's what's happening. But turning to the other part of the question, does it mean is there a chance that we live in a simulation? This has been asked a lot by many scientists, and the only experiment that you can really do to determine that is to look for sort of granularity in some of the fundamental processes. And by that, what I mean is, by granularity, I mean the fact that certain things are quantized. They occur in steps, like the fact that if you look at the charge on a charge up a piece of, well, the old trick, charging up a balloon by rubbing it on your chest and then sticking it on the ceiling, that charge is quantized. It comes in steps because it's measured in electrons. They're single units of charge. And so we know that many things are in steps like that. They're quantized. That's the whole basis of quantum theory. So what about space, though? And what about time? And some people have argued that if you can determine that time actually moves in short steps rather than being a continuum or just a continuous process, and if space can be broken up into short steps rather than being a continuous thing, then that would be evidence that we are living in a simulation, because effectively the universe will be digitized, the whole thing. It's not an analog thing anymore. That's the extent of my knowledge on this. I'm sure there are researchers working on it. Nobody's come up yet with the definitive proof that we're living in a simulation, but it's an interesting suggestion.
It is. Now, before we get to his question on Mars, a question without notice. This came from Richard in New Hampshire, and I'm only asking because it kind of relates. He says, I was watching Brian Greene and Leonard Susskind recently discuss how information was saved to a holograph shell on the event horizon of a black hole. And he goes on to say that the holographic principle could apply to the entire universe.
Yes, that's right.
And he was asking, or suggesting, at the outer universe holographic shell, wouldn't that shell have to keep getting bigger and bigger as the arrow of time and entropy gave it more information to store? If that's the case, wouldn't space-time be expanding along with it as the size of the holograph grew? Couldn't dark energy simply be that the universe has to expand at an ever-increasing rate to keep up with the holographic shell that has to grow to keep up with the arrow of time and entropy? And he wants his Nobel Prize.
Yeah, I think that's a good one. Well, that's right. The holographic universe is still very speculative, I have to say. It was a popular idea probably 30 years ago, actually, when it was first suggested. So we mainstream physics doesn't accept that idea. There's certainly a lot of work being done on information transfer in black holes, and Stephen Hawking had a memorable bet on about whether information could come out of black holes, which he apparently lost because he said it couldn't, and it can. I think that's right.
Right.
Yeah. But look, a great suggestion. I'm not sure that the physics would necessarily hold up, particularly if we don't have a holographic horizon. And who knows?
All right. So to the second part of Lawrence's question, when are we likely to set foot on Mars? The date keeps changing.
It's probably, it's not changed that much. Mid 2030s. There is one of the windows. There's only certain windows for flights to Mars every 2 years and 2 months. Yeah. There's one in 2035, and I think NASA have had their eye on that one for a long time. But the Artemis program to get astronauts back to the moon has slipped, largely due to the pandemic. That's likely that any human Mars program would also have slipped.
Okay. Thank you, Lawrence. Let's move on to one final question relating to going to Mars. We've got a question. I think the name is Bandanoot from the UK. Hey, Professor Fred and the other one. I have a couple of questions. I will only go with the first one. What is the reality of humans settling on Jupiter's moons of Io or Titan? How possible would that be? I think we've touched on this one recently in regard to Titan, or we just talked about what's on the surface of that planet.
Titan's a moon of Saturn.
Saturn,
Jupiter. Yeah.
So what are the odds of settling on places like that?
Pretty low, I would think. Io is highly volcanic. It's the most volcanically active body in the solar system. It's covered in debris from volcanoes. I don't think you'd want to even venture there. I think it's going to be a place that is best observed from above by remote sensing spacecraft. Of course, the other thing about Io is that it's very near Jupiter's radiation belts, and there's interactions of material between the radiation belts of Jupiter and the moon of Io. So it's I would say that's a pretty definite no. Titan's interesting, but it's also a rather unfriendly place. It's got, first of all, surface temperature minus 190 Celsius. You've got a surface which is made of solid ice with lakes of liquid ethane and methane in it, but an atmosphere, and I can't remember the atmospheric pressure, but it's greater than Earth's pressure, I think. Which suggests that you'd a bit like being on Venus, you'd struggle with the pressure. So, of all the places that I could see humans walking on, yes, it's back to Mars. It's Mars is the most similar planet to the Earth, even though its pressure is only 0.6% of what the Earth is. Nevertheless, it has enough in common with Earth that it's a likely place for humans to visit. Not sure about colonizing, as you know. I'm not keen on that idea, but visiting is a different matter.
Yeah. I think there was a science fiction film recently released called The Titan, and it was about sending humans to Titan.
Okay.
But what they had to do is genetically modify them to adapt to the environment, and it turned them into these weird, wild creatures. And I didn't really enjoy the story that much, but it was an interesting theory. I will throw in his second question just as a matter of interest. What are your thoughts on the Pac-Man theory, where the universe is just one continuous loop? So if you kept traveling in one direction in a straight line, eventually you'd get back to where you started from. I'm pretty sure we've tackled this one before.
Yeah, that's the old idea of a closed universe, that space curves in such a way that you wind up back where you started. And the current thinking is that all the measurements that have been made of the universe suggest that it's Euclidean. That means that parallel lines don't ever meet, and so space is in the greater universe is similar to what it is here.
Okay. Well, that one puts that to bed. Actually, we've had a few questions today where the theories have sort of skewed with what the known reality is.
Things have moved on.
We have, yes, indeed. Well, there you go. Thank you for your questions, and appreciate them. And if you have questions for us, don't forget to log on to our website, spacenutspodcast.com or spacenuts.io. There's a couple of ways you can send your questions in. You can do it via the AMA tab, which is up the top. And there you will be able to send an audio question or a text question. Or you can click on the link on the right-hand side, which basically asks, send us your voice message. It's actually more of a demand by the look of that. But anyway, that's how you can do it. And while you're there, have a look around Astronomy Daily, the shop, also how to be a member of Space Nuts. There are membership options there as well. spacenutspodcast.com or spacenuts.io. That wraps it up, Fred. Thank you so much.
It's a great pleasure, Andrew. Always good to talk, and we'll speak again soon.
We will indeed. Professor Fred Watson, astronomer at large, part of the team here, and thanks to Hugh in the studio who does all the not so essential and non-hard work to put it all together. Thanks, Hugh. And from me, Andrew Dunkley, thanks for your company again. We'll catch you on the very next episode of Space Nuts. Bye-bye.
15 seconds. Guidance is internal. 15 seconds. Guidance.
That would be wrong. Where's the end? There it is.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.